Think math.
Look at three lists. N squared grows without end, minus n falls without end, and 1, minus 1, 1, minus 1 swaps between two values. None of them has a limit, so all three diverge. But calling them the same thing feels wrong. Divergence itself comes in kinds. First, divergence to infinity. Pick any large number you like, and far enough along every term of the list sits above it. Take 1,000,000. Once n passes 1,000, n squared is above 1,000,000, and it stays above from there on. Take 1,000,000,000, and the same thing happens. Any number you name, the same thing happens. That is what we write with an arrow to infinity. It does not say the value is infinity. It says the list grows without end. Minus infinity only reverses the direction. Pick any small number, and far enough along every term falls below it. Minus n runs minus 1, minus 2, minus 3, always downward. Pick minus 1,000,000, and the list drops below that and never climbs back. So it diverges to minus infinity. Up or down, the point is the same. It goes one way, all the way. Last comes oscillation. 1 minus 1, 1 minus 1 goes nowhere at all. And here is the example that catches people out. Minus 1 to the n times n. It runs minus 1, 2, minus 3, 4. The size keeps growing, but the sign keeps flipping. It goes neither up nor down, so we cannot write infinity. Growing is not enough. It has to grow one way. Why bother splitting them? All three share the same fact. There is no limit. But the word infinity carries a direction with it. Add two lists that both run to infinity, and the sum runs to infinity, while two oscillating lists tell you nothing about their sum. And there are places like infinity minus infinity, where direction alone is not enough. That is why divergence is named in three kinds rather than one. To sum up, divergence means there is no limit, and inside it, there are three kinds. Rising above any large number and staying there is infinity. Falling below any small number and staying there is minus infinity. Settling on no direction at all is oscillation. Growing in size and going one way are not the same thing. Next time we turn closing in into a single narrow band. A sip of math. Every day, here at Think Math.